Okay, and with that, I'd like to introduce Ben Beyer, VMware Senior Systems Engineer, who's going to be speaking on NSX, security at the speed of business. Ben?
Hey, thanks a lot, Neil. My name is Ben Beyer. I hope everyone can hear me, and I took myself off mute correctly. I'm a Senior Systems Engineer with VMware. I work in the Network and Security Business Unit, so my focus is almost exclusively on NSX for networking and security. And so today I'm just going to give a, kind of a brief introduction to NSX as a platform for network virtualization and also for security virtualization. When you think about NSX, we like to think about NSX as part of the software-defined data center. So it's a piece of what VMware is trying to do and is succeeding at doing, and that's defining the entire data center in software. So the idea is to take all the intelligence that are in ASICs and all the configuration that you do, piece by piece today, and put that all into a single, set of software products so that you can control all that, control your entire data center sort of as a single application, right? Bring all the intelligence into software and provide an operational model that we get with, virtualization for VMs to the entire data center, right? I can spin up whole applications and platforms and spin them down and clone them and do all that good stuff that I can do with VMs, but for everything. So the software-defined data center has, three kind of main parts that we see. The virtual machines, the server virtualization, the virtual storage, and finally the virtual networking and security. And so this discussion, really focuses on only the networking and security. So what is NSX, right? In brief, we'll start with the data center, right? The data center has, switches and it's got some routers, right? And these are physical switches and physical routers, and they're connecting, everything in your data center together, right? And by everything, a bunch of servers, right? And in those servers, we've got hypervisors, typically, if you're highly virtualized. And, we can also, NSX also has services for, physical workloads as well. But for sake of this discussion, we'll really focus on the virtual workloads. So we've got these virtual workloads, and each of these hypervisors has a vSwitch in it, and that's where NSX plugs in. And NSX is essentially an overlay network, that exists within the hypervisors and lays on top of the, on top of the data center, right, on top of the compute resources. It does not interact directly with the physical switches and routers. It's purely an overlay technology. That makes it very easy to deploy, right? You don't have to, recable anything. You just install some software on your hypervisors and you're good to go. And it makes it very flexible as well, right? If you're thinking about, mergers and acquisitions or things like that, when you get a new data center and you're trying to, maybe incorporate that into your current scheme, you don't have to replace any hardware to get the benefits of NSX and to do your networking with NSX. So NSX is this, sort of brown, or blue box right now. And what do you build with NSX? Well, you build all the, regular components of networking, right? Logical switching, logical routing, load balancing, I mentioned the physical to virtual bridging and compatibility, and firewalling and security, right? And so you can build all of these constructs, switching and routing and the load balancing, and the security, and do the physical to virtual bridging. And you can build all these without having to change the underlying network configuration. So when you're using NSX to build all these services, all these network services, you can do this out of a cloud management platform because it's all software, it's all API driven. And so all of these services, the routing, the switching, firewalling, all of that is provided by NSX independent of the underlying physical equipment. I hope that is making sense to everybody, right? Please feel free to ask questions in the panel, and I see them coming up so I can address them. So distributing everything out to the hypervisors, right, comes with a bunch of benefit. I'm going to use the mouse here to point. If we look at traffic flows between maybe two VMs, right, if they're on different subnets and I want to firewall between them in the traditional way that I configure and build data centers, that traffic's got to go all the way out to a physical firewall somewhere and then come back in. So if these two VMs are on the same blade, that traffic has to exit and go, halfway across the data center, get firewalled, and if it gets through the firewall, it comes back, halfway across the data center and gets delivered. With NSX, that doesn't have, the traffic doesn't have to go all the way out to the data center because the service is provided. In this case, this is, the firewalling, but all of these services are provided in a distributed manner. Because the service is provided out at the hypervisor, the traffic never has to leave the hypervisor in order to get the firewalling applied. So, in the same sort of scenario, if you're going from, hypervisor to hypervisor, you're only sort of going the minimal distance to get between those hypervisors. So this picture is on, a UCS chassis. You're just going up to the fabric in order to come back down to a blade, still as opposed to coming out to the firewall. So that's kind of, I use this slide to try and, give an idea of where these, where the functionality is being applied. So if you're thinking about sort of the bits and bytes and where the packets are going, this is kind of a picture, to help understand, okay, it's staying here local at the hypervisor, right? All these services are at the edge. And so let's talk about, network security, right? So talked a lot about sort of the network overlay stuff, but let's focus in here on the security, right, the topic of this talk. If we look at, how data centers are built today, it's very easy to put some firewalls out at the internet, right? You can block traffic and filter traffic coming in and out of your data center, but it's extremely difficult to build firewalls, to build a regimen of firewalling inside the data center. It becomes operationally very difficult to do that. So it turns out that putting, firewalls at the edge and protecting the firewall doesn't get the job done, right? If we look at a lot of the major breaches in the past couple of years, Target, for example, that came in through the HVAC system, right? That was plugged into the network, so the maintenance company could get updates, and there was no firewalling between that and the rest of the network, and so that's how the attackers got in. So it's not, security-wise, it's not enough to put firewalls out at the internet. We need to get to the point where we have firewalls between all of our workloads, but that's really, really difficult to do in the traditional, data center, right? We're talking about multiple VLANs, and you've got to, if you want to firewall something differently, you've got to maybe move servers around and re-IP them. This is extremely difficult to put into practice. NSX addresses this by distributing these firewalls and this enforcement all the way out to the hypervisors, all the way out to the edge of the network. So we're protecting traffic where it originates. Right? So how do we do that? Right? Well, I've got this example. We've got two hypervisors, and traffic's going to flow. Right? So with a traditional firewall, the firewall sort of at the perimeter, or a firewall, at a distribution or aggregation layer, traffic's going to come from the VM, and it's going to flow to that firewall across the physical network, right? And then it's going to get, acted upon, blocked or allowed or whatever. Right, log. The point is that traffic has to go halfway across the network, right? With NSX, I define my security policy in the cloud management system or in the NSX console, right? And that security policy is not just firewall rules. That includes, antivirus and IPS and a bunch of other rich services security services that you want to have, right? You define that security policy and attach that security policy to a VM. Then when that VM is deployed, the security policy is deployed with it. And so if you've got, notice I haven't talked about, writing firewall rules via IP address, right? I'm applying the security policy to the VM. And because the hypervisor knows the IP address of the machine, those firewall rules are implemented with the, specific IP addresses for that virtual machine. When that traffic now flows, that enforcement for the firewall or the IPS or whatever security service you want is enforced at the hypervisor. right? So if it's blocked or dropped, that traffic isn't flowing across half the network anymore. It's being addressed immediately, upon origination. When the VM moves, right? Sorry about the artifacts, guys. I tried to fix some of these animations last night, but apparently I didn't do a great job. When the VM moves, the security policy moves with it, right? So if you vMotion the VM, and most importantly, when the VM goes away, the security policy goes away as well. So if you've ever seen a big firewall rule set, maybe a few thousand lines, there's definitely rules in there for the most part that, for most implementations, there's rules in there that no one really knows what they do. So you just leave them there so you don't break anything. It never happens with NSX. Because the rules are implemented per VM as the VM is deployed, and then as the VM goes away, those particular instances of the rules are taken away. So let me dive into that a little more, or let me talk about the security services that we offer. So, we offer the firewalling, right? And we also offer a platform to hook in third-party services. So this is antivirus, Trend Micro, McAfee, or I guess Intel Security, and Symantec, and DLP, and vulnerability scanning. These are, host-based services, right? And then we also offer, a platform for the integration of network-based services. So IPS, next generation firewall with Palo Alto and Citrix and Fortinet and load balancing with F5, right? All of these network services plug into NSX so that we can offer them holistically as a security policy that's more than just, the firewall rules, right? So how do we do this? Well, the first thing we do is we need to identify machines, and so we can intelligently group virtual machines in order to apply these security policies. So I can, identify virtual machines by the operating system, right? If I've got some old 2003, Windows servers, as virtual machines, and I've got those hanging out there, and I know that, they're not being supported anymore by Microsoft, really I want to maybe apply some extra security to that. Make sure to get those behind IPS because I know they're unpatched until I can get them migrated, right? I can make a grouping in NSX and really using vCenter constructs and say, hey, vCenter knows what the operating system is, right, which it does. If vCenter knows what the operating system is, and if that operating system is, Windows 2003, for example, put all those together in a group. And that's completely regardless of whether those are, on different VLANs and different subnets. The IP address doesn't matter, right? I'm going to group all those together, and then I'm going to apply security rules to that, firewall rules or IPS rules or antivirus or whatever, right? Whatever security constructs, I'm going to apply that to this group, right? So go here to the next page. I define this policy, and I assign my services, right? So, hey, I've got this group of Windows 2003 servers, and I want to make sure they get an IPS. All traffic in and out gets addressed by the IPS. That would be assigning the service. And then I apply this policy to the grouping, right? And I don't have a grouping picture here of the Windows 2003 servers, but if, I've got web app and DB, so I can, hey, my web server, maybe I want to have IPS, but the app servers I don't need to because, I'm firewalling, them off from the internet or something, right? Whatever security policies, that you need for your workloads, those are very easy to apply, right? And you're applying these to the workloads and not having to worry about, what subnet, any of the virtual machines are on or what the IP addresses are. You're not writing sort of these rules, and you're not directing traffic using the design of the network. You're just applying this at the very edge of the network in the hypervisors. I hope that makes sense to everybody. Please feel free to ask questions or pipe up. So this allows us to do some things that, are not really possible in today's world, right? We can automate security operations using all of these different third-party, security platforms, right, and firewalls. So we can do things like, hey, if I find a virus on a virtual machine, right, because maybe I've applied, the security service of antivirus, if I find a virus on that machine, well, I want to make sure that that machine gets quarantined with firewall rules, right? And we do this, NSX does this by providing a common communication platform between these third-party services so that the third-party services don't even need to know about each other, right? The virus scanner finds a virus, it uses a metadata tag and says, hey, this VM has a virus. And then NSX, looks at its policy and says, hey, anything with a virus, I'm going to make sure that I quarantine that off with the firewall rules, right? We can do that for, hey, if you find a vulnerability, right? We can have vulnerability scan, plugins with, Rapid7 vulnerability scanner. Hey, if we find a vulnerability, maybe we want to monitor this VM with IPS, right? If you think about how you would try and perform these operations, right, sensitive data found, allow and encrypt or restrict access, right? If you think about how you would apply these, these operations, right, how you would perform these functions in today's data centers, right? Oh, if I find a virus, I've got to go track down that virtual machine, right? I've got to figure out which hypervisor it's on and manually go in and sort of do this. By using NSX and automating this, we now have functionality that just wasn't possible, 4 years ago, right? 3 years ago before NSX came out. And this is this multi-platform, multi-security service coordination and automation. I hope that makes sense to everybody. So the security operations are automated, and they adapt to dynamic conditions, right? So, if you have something set up where you're doing, vulnerability scanning, right? With the Rapid7 party, and it goes through, and then there's a new vulnerability that comes out, and Rapid7 is updated, right? And you say, oh, if it's Rapid7 finds vulnerability, make sure the IPS scanner is scanning it, right? That happens automatically, right? You don't have to go in and perform that action, or without. This happens without having to worry and without having to react, right? So to talk about sort of where NSX is being adopted, I have a bunch of names up here. We have tons of logos of public companies. So I'll say, I've been with VMware for about 3 years now. NSX has been out for 2.5 years. In its current form, and we've gone from 30 customers to 700 is what we announced last year. Our earnings are coming out, so I can't tell you how many we have right now, but it's certainly a lot more than 700. And we are growing rapidly, so we have penetration pretty much, in every industry at this point. 3 of the top 5 financial firms in the world are using NSX at this point. And the focus is, for a lot of these companies, the focus really is on the security part of this, right? If you think about, providing that security, providing firewalling, and providing, sort of multimodal security all the way out at the edge of your network in the hypervisors, and you can provide this firewalling and provide the security without having to, re-IP servers. We find that NSX, enables companies to rapidly secure data centers the reactivity also helps with, just the deployment, right? So as opposed to, hey, I need to buy new big firewalls and move servers and try and re-IP, and those projects take multiple years, we find that NSX actually deploys and gets companies secure in, a few months as opposed to years. So that's about all I have. Does anyone have any questions?
Awesome. Thank you so much, Ben. It looks like we do have a couple of questions coming in, so I'm just going to take back that mouse control. Let me get in there. Again, just as a reminder, if you have any questions, it's not too late to post them to the questions pane and we'll fit them in. We do have one question coming in. Actually, there are several, so I'll go right down the list for you, Ben. First question, I think I have a handle on the capabilities of NSX in the context of guest OS level networking. Are there any capabilities of NSX from the perspective of how the hypervisor hosts consume storage. We leverage a private storage network and present data stores to ESX via NFS and would like to have greater control and granularity within that side of the environment.
So today, our approach hasn't been to use NSX to actually control storage network stuff. The idea that we've gone with so far is that NSX is sort of independent of the storage backing and the compute backing. So, your physical network underneath would, probably have dedicated VLANs to the storage. NFS in this case, or iSCSI in some people's case, right? So you'd have dedicated VLANs to that, and that would actually run completely independent of the NSX traffic. Our focus with NSX is really to provide, greater security and control for the guest VMs. I hope that answered that question.
Great. I'll be sure to track any follow-up there from the audience member if there is. So thank you for that, Ben. We do have a couple of others. Does NSX work with physical workloads? I know you mentioned early in your presentation, Ben, that it actually did, but I'm assuming from the question they're looking for a little bit more detail maybe on how that's actually done.
Yeah, absolutely. So there's right now there's two ways to get physical workloads sort of protected by NSX or being serviced by NSX. In the first case, we have a software bridge, that pushes through 7 gigs, I think. So you can bridge an entire VLAN, right? If you've got a bunch of servers on. We also have partnerships with a large number of switch vendors, Brocade, Arista, so on and so forth, and that allows us to extend our logical switching all the way out to the individual server ports. So think about it like extending our logical overlay switching and extending that in the same manner that you would extend a VLAN as an access port. Right now, that's sort of, hey, we can do the routing and the switching, and we can do centralized firewalling, the distributed firewalling, and that kind of capabilities to make those stateful is really kind of waiting on the Trident, the next iteration of the Trident chipsets in the merchant silicon switches. In order to make that stateful, a lot of the switch vendors have non-stateful firewalling. So I don't know that it's firewalling, but more ACLs out at the switches today. Does that make sense? Well, I guess really you're probably typing, so.
Yeah, I think that that helps a lot. It kind of gave some info in the state of the state, and it sounds like there's more to come on that front. So definitely keep an eye out there. We do have one other question, it looks like. This is an interesting one. I'm sure IT budgets just are perpetually constrained these days, so I'm sure this is related to that. Do you need special hardware for NSX to work? So that's a great question. What are your thoughts there, Ben?
Yeah, so you don't, right? NSX basically, if your hypervisor runs ESX, it's going to run NSX. Right, there's obviously drivers with the NIC cards and stuff like that, right? We're going to make sure we have the right drivers and stuff. But NSX runs on the hypervisor, so in terms of network equipment underneath, that anything that passes IP packets, right, will work for NSX. In terms of the hypervisors, I think there's like a couple quirks or something in the server builds, but I may be mistaken there. But basically, anything that runs ESX runs NSX. So, I mean, that's really our goal, is to not tie anything into the hardware, because we're able to sort of move much faster and develop and deliver services if we don't have a hardware development cycle. So, philosophically, our goal is to never really be dependent on the hardware beyond basic compute.
Great, thank you. There is another question. What is the resource usage of NSX on the physical hardware that VMware ESX is running on?
Yeah, good question. So typically, NSX really takes CPU cycles, right? And typically that's around 2% in a typical workload. If you're running something crazy, right, we've seen about 6% CPU utilization in addition to what the VMs are running. And that's something crazy, right? We had a video game company, and they have tons and tons of tiny little packets, right, UDP packets for the guns or bullets or whatever in the video games, and that actually ran about 6% CPU usage, but in the typical enterprise, we rarely see anything above 2% CPU utilization.
Great, thank you.
Make sense?
I know
okay.
It does. Thank you. I know we're getting close to time, and that actually concludes our Q&A from the audience at this point. Before we let everyone go, I do want to thank you for your time and attention, and of course to Ben for some great and very timely information on the security front. So thank you, Ben. Great.